aurait contribué à calculer la note minimale compressée. Parce que, évidemment, j'aimerais bien aller choper ça.
Okay, on start.
Ouais, attends.
Please have a seat. Okay. People, please. First of all, I don't mind speaking English, but I would prefer to speak in French. Does anyone don't speak French in this room?
Yeah.
Okay, I will do it in English. So, I'm Cyril. I come here to do this DevOps, Docker, and observability class. I did EPITA more than 4 years ago now. Yes, 2020. Let me introduce the course a bit first. I like to start each course by this slide. Why should you listen to this course? Because I am making the presentation to you, and you have two choices here. Either you come to the class and listen to me and try to understand the concepts and ask me questions when you don't understand and try to challenge me on some topics, or you can choose to come and play video games on your computer or stay at home. This choice is up to you. I don't really mind if you come and don't listen to me, but I would prefer you to listen to, and I'm giving you reasons for that. The first of all is we are going to talk about some concepts you most probably, for the majority of you, haven't heard of. That is production. Right now, if I'm not mistaken, I'll make some assumptions about most people in this room. So far in EPITA, yeah, please have a seat quickly. So far in EPITA, all of you have been coding. You have been creating softwares, like small pieces of code that make stuff. And after the deadline, after the project submission, the code was moved to virtually trash, like it was never to be touched again, never to be used again, except by the IQ that will like run some booleanet on it. But except for that, the code is virtually useless. You have learned from the code, but the code doesn't serve any purpose anymore. This is not real life. In real life, of course, you will be paid to write code, and the code needs to have a purpose. Either it will be sold to some customers, or it will be sold as a service to some customers. In the end, the code will be used. And to be used, we need something that is called a production. We are going to talk about the modern world, about software as a service, SaaS, if that's something that rings a bell to you. Okay, sort of. So software as a service is the new way of seeing software development. You're not selling code anymore. You're not going to some software shop somewhere in the downtown to buy CDs of some I don't know, Adobe or whatever software. No, you are buying subscriptions to an online service that does the same thing for you. You don't buy videos anymore. You go to Netflix and pay a subscription. And in the end, you have Netflix, which is not only like the videos, but also the platform that allows you to watch those videos. And you have it as a service, like it's a service you have. It can be free, like YouTube, where you don't have to pay for YouTube. Well, you can, but you don't have to. Or it can be paid. It can be B2C, business to client, or B2B, business to business. For example, the company I work for, we are a B2B company. We are selling a software as a service, but you have never heard of it before, most probably, because it would be useless for you individuals. It's only useful for companies. And all these things leads to this sentence here. We need a production. We need to have servers on which the software you have built will be running and will be accessible, made accessible to the customers. If you don't have this, your software doesn't serve any purpose. So this is some topic you have never heard of in Epita before, if I'm not mistaken. So it will be quite interesting. And it's also very connected to reality, because most of you will work in companies where you have a production somewhere. Some other reason is that we were going to talk about some state-of-the-art notions here. I'm not sure how well Epita evolved, but I remember having some courses about things that were outdated for 15 years. Hopefully this is not the case here. All the content of this course is updated every year, and on top of that, the content is still widely used by most people in most companies, okay? So we are not going to talk about some niche project or some, I don't know, compiler I have created on my spare time. No, we are going to talk about like big projects, like open source projects, but also the title of the course says craftsmanship. I don't like this word because for me it's like some bullshit-ish word. I don't understand it. I would say methodology sounds better. You people understand that. We are going to talk about some methodology that is still widely used and that we need to understand. If you want to get a job, for example, you look on LinkedIn, you look at DevOps, you'll see hundreds of job offers. So we are not talking about some niche subject here. On top of that, even if you're not working in the DevOps field later on, you will still learn about some tools that will help you vastly, that will make you proficient. A lot of those tools that were developed for the DevOps approach or that were used mainly in the DevOps approach, the tools that are like strongly connected to DevOps, you cannot see one without the other. Some of these tools were like so powerful that they are still used by everybody else. So let's talk about those tools too. And fourth point, the subject is somewhat difficult. This is something that is still not well understood. We don't have enough people that understand this subject in I would say in the wide. Like we are trying to hire people and there is no one on the market. Because this subject is quite difficult. It's less obvious than starting to code. Like, I don't know, but most probably a big part of you started to write code because you were interested in, I don't know, hacking a game or writing your own whatever small project, writing a website or something like this. Nobody starts like working in the IT field by saying, oh, I'm going to do DevOps, because it doesn't ring a bell to anyone. So, of course, it's about taking the next step into IT development. I would say it's the best step, but it's another one. Nobody starts with DevOps, and it's a bit difficult to get into as well. So let's use this course as an introduction to the field. And of course, the last point, I don't like it, but you have to take a test that is some kind of project that you will have to do during the semester. And of course, you will have a grade on this one, and you would like to get a decent grade. Don't worry about it in terms of the grades. Last year, I think we had like a good average of 14, I think something like this, and a median value of around 14 as well. Frankly, it's quite okay to have a grade. I'm just asking you to work a bit. There is like I think 10 hours or maybe 15 for the project for the whole semester. This is manageable. And I'm asking you to start early and to not cheat, of course. A lot of people, like the average value was pulled back a bit towards 0 because frankly, and this is very saddening, but a lot of people cheated and they got 0. Not only that, some people started, I think, 1 day before the deadline and of course didn't manage to get any points. But we'll talk about this a bit later on. Any questions on this? Okay, a thing I have not mentioned, but I would like to have interaction if possible. I know it's quite hard because it's way easier for you to sit and listen to me speak, but I don't like speaking alone for 2 hours, and today it will be 6 because I have to do this course 3 times. So if I can have some interactions, if you have some questions, if things are not clear, please let me know. Yes?
So the project and everything, even the slides will be available on Moodle or not?
Yes. I haven't looked into Moodle yet because I don't like this tool, but I know that this is the official one, so I will have to get into it. I will put the slides and the project as soon as it's released because I need to polish the last bits, like sentences of the project. As soon as it's ready, I will publish everything on Moodle.
What's the project going to be about?
DevOps.
Yeah. No shit.
This course has 3 or 4, let's say, face-to-face lessons like this one, and we have 2 practical stuff on the computer room above. On the 2 times 2 hours, I think, that we'll have spent working on the project together. We'll get started on this project, so we will have, like, I estimate the project to be 10 to 15 hours long. Out of those 10, 15, you have already 4 that we'll do together, and the project will be exactly about the content of the course. The first part of the course is, actually, I think it's the next slide. No, it's not. Let's skip one. Yes, this one. The first part of the course is some concepts, some, I would say, yeah, we're going to talk about methodology, about DevOps as a concept, and then we'll start with some like real tools and things I can evaluate you on. The first part, I cannot really evaluate you on this one, except doing some, I don't know, MCQ or some written exam of like what is DevOps, what does dev means in DevOps or things like this, which is not interesting, which is frankly boring. So I will just hope that you listen to me on the first part because it will get you started on the next, and you will be evaluated on Docker, Docker Compose, a bit of Git workflow, and observability. You'll see in time. I just need to finish. I don't think I'm going to talk about the project anymore on this course today. Next week, or in 2 weeks, I don't know when the next course is, next class, we'll talk about this. Okay, so the slide I skipped. Who am I? Because I'm talking to you. Maybe you'd like to know a bit more about me, like why should you listen to me? Who am I to talk about DevOps? So it's quite interesting for you to understand my profile and especially my point of view. I just said that for the majority of you, you have so far in Epita only written code. You are considered developers to me. I may be mistaken on few profiles here, but for the vast majority of you, I think this is true. This is not my case. I don't write code anymore, at least not the same kind of code as you do, and very little amounts, and it's very poor quality as well, because I'm not a developer. I am an ops. I am working on the other side of the DevOps. If you have not understood it already, DevOps is the world development and operations, concatenated and shortened. So I am not doing the same work as you do right now in Epita. And because of that, I don't have the same point of view of things. I care about things like production, while you don't care because it doesn't matter to you. And this is important for you to have this in mind because we will be challenging ourselves. We'll see a bit later on why. I went in EPITA in 2020. I have done some things, meaning that I was an ops at EPITA while I was EPITA, and I have been working in like DevOps context for more than 8 years now. The other part is I know EPITA, I know the students. I was one of you a few years ago. I was sitting in this very room. So I know how you work. I know how you like to understand things. I know how you like to take shortcuts if you can. I know how you can try to cheat. I know all these sort of things. I know what interests you. So I will try to use this as best as I can for this course to be useful to you, interesting, and somewhat fair in terms of grading. Okay. My official title is DevOps Engineer, which doesn't make any sense, and we'll see later on why. In fact, I am more an SRE, Site Reliability Engineer, or an Ops. Okay, those are two different concepts. It's very hard to put labels on the actual work people do. Those are the closest label that actually match reality. DevOps engineer is the generic one people understand on LinkedIn, on company market and hiring things, okay? They have never heard of SRE, so we have to go with DevOps. So not a dev, okay. So, I think we can get started and ask yourself what is DevOps. Does anyone know, like, who has some kind of idea or has been introduced to DevOps first? Yes, please.
Basically, DevOps is a set of concepts and the pipeline that it's already in the meaning of DevOps that takes some code from it works in my machine to proper production.
Okay, this is quite the definition to get started on. Thank you. You have an idea?
I would say there's on one side the developer who is just coding something that works on his machine. On the other side, the infrastructure engineer that is making things work in production. And the middle case is DevOps, the one who knows how the code works and how the infrastructure works to do the work necessary to make a project ready to be deployed.
I like your definition because it's quite true. The thing I don't like about your definition is you think that there is a person who is in charge of DevOps, like who has a DevOps engineer title, which is opposite to the DevOps movement at its core foundations. I'm going to talk about DevOps with the grumpy ass who has been talking about DevOps for years, where people are very strict. No, DevOps is this very thing and not the thing people made out of DevOps. DevOps has evolved. It's boring and annoying to say that DevOps is not a proper title because you can see DevOps engineer titles on LinkedIn, so it's actually a job. So I'm going to take this this step back and try to stay very how to say, squared on the definition, even if it's not very true anymore. So according to the true definition and true meaning of DevOps, DevOps is not a job, it's not a person, it's actually a movement. It's a methodology, it's a set of tools, it's a set of good practices, and all this stuff that indeed make what you described happen. Developers and ops that work on two different subjects with different objectives work together and manage to go in the same direction instead of pulling their side of the rope and try to make the other team fall. Okay? Okay, so development, of course, you know what development is, creating code, applications like writing JavaScript, C or C# or whatever. What drives the developers is to have a will to introduce changes, either new features, either bug fixes, but they want things to move. You're not writing code to keep the thing the same, okay? You want things to be a bit more stable maybe, you want to fix some issues, UI issues, UX issues, whatever, you want to change things. You will be working mostly on your laptop with an IDE, you will be opening Vim or Visual Code or whatever, and this is about it. The operations, on the other hand, this is the thing you're not familiar with so far, I guess. the point of the operation team is to ensure services are working and available. So this includes the aforementioned developed applications, okay? You're not developing the application for nothing. The ops take this application and make it run and make it available 24/7. The operation team, on the other hand, they don't want to break anything, and something that doesn't move, something that stays the same, is less likely to break. So you're reluctant somehow to change. You don't want things to change. If it's stable, introducing a change is introducing a risk of things to fail and a risk of things being less stable. So we have the first, we say, opposite directions. The dev want things to change, the ops don't want things to change. Somehow they will have to agree, because upper management, they want things to change, but they want things to be stable. They want both things. They want both, the best of both worlds. So we'll have to find something about this. The work environment of operation team is mostly working on the servers, on the VMs. Usually you just need a text editor, you don't need an ID, it's too big for us. And SSH. You know SSH? Yeah, okay, remote access. You open a remote shell and you work on the servers remotely. Okay, so I have said already, it's a set of tools and practices. And the point of DevOps, like why do we came up with this word and this whole thing, is to reduce or even remove the friction between the dev and the team and the ops teams. A way of doing this would be to have the devs doing a bit of ops and the ops doing a bit of dev. So you will have people in the dev team that understand the ops point of view. They have a bit of knowledge. They're still strongly tied to the dev team. They're working mostly on development, but they understand a bit the ops. And when they discuss, especially with the ops that does the opposite thing, they can understand them, like both of them, better. They can understand the problematics. They can understand how things are supposed to be done. Okay. So, as per the original, very strict and very, I would say, excluding definition, DevOps is not a job per se. It's like tools and practices, and you can argue that those two guys, the dev that does a bit of ops and the ops that does a bit of dev, both of them are DevOps engineers. That would be true, actually. And this is why I need to precise, I need to specify that I am not a dev doing a bit of ops, what could be called DevOps engineer, but I am the other kind. I am an ops that does a bit of development. You don't want to see my code, actually. Some DevOps tools are so popular because they were created for this kind of problems that became new standards. I'm talking about Docker. Most probably you have heard of this tool, for example. And I think one best way of understanding exactly how this whole thing works and how people interact would be to have this diagram. We are representing here some small-ish company. This is an example. All the boxes are, I would say, not inaccurate, but they can vary from a company to another, especially if you're talking very big or very small companies where people will be in 5 boxes at once. But let's get started with the most important person in the office, the CEO. Of course, the CEO owns the company, or at least not in the US. In the US, mostly they just operate, but they have a fair share of the company, and they get the biggest pay of the company, of course. And right under the CEO, there is the CTO, Chief Technical Officer. The CTO is in charge of all the technical part. He doesn't want to understand about selling the product. He just cares about the product itself. The product being the things being developed and operated and sold to the customers. And as part of its duty, he is in charge of all the technical teams. That makes sense. The T in CTO, technical, okay. You can see that as first of all or last of all, depends on how you want things to be shaped, but let's start with first of all, the sales. You want to sell, you want to make money. This is the point of a company. It's not to provide a service, it's to make money. So you need for that most probably sales or a marketing team or people that are going to attract customers and sell them the products you are building, going to build, have built already, depending on how well established you are and what kind of money you want to make. But the sales team sell things to people and are in contact with the product / project team, the people that will be shaping the product. Like, okay, I'm working on what kind of example can we have? Okay, we are working at Boulangerie Express. We want to have a service like Uber Eats, but just for boulangerie things. We have like this website. We want things to be able to order croissant very fast and very easily, very convenient. All these things. You have the perfect sales pitch, but you need to design the product the right way. Okay. This is the role of the product team. It's to find how Boulangerie Express should be shaped. What will be the user interface? What people will have to do in order to buy a croissant? What kind of steps? Do they have to create an account? Do they just have to provide a credit card information? How do you want things to be working? The product team doesn't know code well, but they know how things should be shaped, and they know how to manage projects, and they know how to do these kind of things. So they will be shaping the product on some design papers. They will be making a lot of bullet points lists saying, okay, I want this feature, I want that, I want this thing to happen when this thing happens. Those sorts of things. So of course the product team is in direct contact with the developers. I'm very sad to inform you that developers don't choose what they will be developing on in real companies. You don't come to work on a Monday morning and say, okay, I will try to work on this piece of software I find amazing. No, some people will come and say, you will be working on this feature because we need it ASAP. You will be fixing this bug, even if you don't like this, this specific bug, or if you don't want to work on this feature yet because you would like to work on another one, you're not the one who decides. Unfortunately, this is the product team. So developers, they will be creating code, okay? And at some point, the code will have to be tested. The code you write is not perfect. Sorry to inform you on that. I think you know it already, but your code is not perfect. It contains bugs. Sometimes it fails for some random reasons, and sometimes you have forgotten corner cases, okay? So they will be discussing with the QAs, quality assurance, okay? Do you know the joke about the QA engineer that comes to a bar?
Yeah. Yes.
Yes, okay, 2 people. Okay, the role of QA engineers can be summed up by this joke. A QA engineer comes to a bar and he asks for 1 beer, then he asks for 2 beers, then he asks for 0 beer, then he asks for -1 beers, then he asks for 2,099,000,000, etc., beers. Then he asks for a lizard, because why not? And things are okay. The bartender is still serving and doing its job. And QA says, okay, everything is good. We can release the bar in the production. So you open the bar and you have your first customer that comes to the bar. The customer asks for the toilets and the whole bar explodes. This is the role of QA engineers. They will be trying to find as much bugs as possible. They will try to test as many cases as possible, even things that don't really make sense. Because in the end, the customers will either do that voluntarily, or because they are stupid sometimes, or because they want things bad to happen. So they will be trying to input wrong information. They will be trying to break your product. So let's try to break it internally first and solve the bugs first. As soon as the product, guys, as soon as the product is developed and well tested by the QAs, then we have the ops team who's in charge of putting the application on some server and making it accessible to customers, making sure that things are redundant. Like if you have one instance of your application, if it crashes, no customer can connect to your application anymore. If you have one instance of your application on one server, and this server dies, because this is what servers do. They sometimes randomly die, okay? Or the hard drive dies. You must probably have already a hard drive that failed on your personal laptop or computer at home. These things tend to happen. And if you are unlucky, which you are by definition of Murphy's law, if something can go wrong, it will go wrong. So if you have only one instance of your application on only one server with only one hard drive, if you lose any of those components, your application is not accessible anymore by the customers. And if your application is Boulangerie Express, it means that you're not longer selling croissant, you're not longer making some money for the CEO to buy his third Ferrari car, and that would be very saddening for the CEO. So the CEO will come to you and and tell you that you're not doing the right job and you have to work better so he can buy his fourth Ferrari car, of course. So this is very important. All those people are working in the end to have a product that is sellable, that makes sense, that can be used by the user, and that can be used 24/7 in a reliable fashion. Then we have a few teams. I have put dotted lines around the boxes because they're not. They might vary from a company to another. Some companies might have a dedicated architecture team, security team, voice over IP team. Depends. It doesn't really matter. It's just to illustrate the point. On most companies, you don't have only one dev team. It doesn't make sense. You have 20 smaller dev teams, okay, with an S. Does it make sense for you? Okay, I think it's fairly simple. Yes?
What's voice over IP?
You know when you call on Discord or on Skype, if you're too old for Skype, this is voice over IP. And some companies, they have voice over IP engineers because, like for example, if you're working at Discord, you want your voice over IP to be very reliable. I have put voice over IP because this is one of the teams we have at my company because we are a call center software as a service. So we have we are how is it called? Opérateur téléphonique in France. So we do sell phone numbers and phone-related things to customers. So we want those phone lines to be reliable, to have good quality, to have no latency and things like this. And it turned out that it's quite complex, very hard, and you have you need dedicated people that work on this 24/7, not 24/7, but a full-time job. Okay. Let's look at the other side of the diagram. On the other side, we are looking at how the product is developed. Okay, so the very first step is local development. The very first thing you will do as a developer is open your IDE on your laptop, git clone the project maybe, and start working on it. So you will be working locally, writing code. At some point, the code you wrote compiles somehow, and you think, okay, I have finished this feature, I have fixed this bug, I have done X. Let's try to release this because the client will need it and it will be a great addition to the company's project. So as soon as you're done with local development, you go on the test phase on some staging platform. At Boulangerie Express, we have a few platforms. We have the platform that the clients will connect to, but not only. We also have a staging platform. And on this staging platform, we try to have a Boulangerie Express instance of like the whole thing that works, but only for development purposes. You have added your feature, you want to test it, you go to the staging platform, you release, you see how it behaves, if it's working fine, and if that's okay with you, you have done your basic tests, which usually consist of only trying to see if it compiles, and if the code compiles, you move next to the RC. What does RC mean?
Release candidate?
Yes, release candidate. Thank you. So release candidates, you have worked on your application, you have worked added features, and at some point you see, okay, let's stop here. We have added enough features, we have corrected enough bugs. We want to release that to the customer. So we freeze everything. We say, okay, the code doesn't move anymore. We put a label on it called release candidate, and we say, don't worry about the slides, they will be public. We say this is a release candidate. We were on version 15 so far, and now we're trying to release version 16. So let's put a release candidate tag 16, saying, okay, this looks like a fine candidate for the 16th version of our application. and we move forward to some other platforms, which names are QA. I think this is fairly straightforward, quality assurance, PPR, pre-production, and SBX, sandbox. Those are like some, I would say, random names or some names you can come across. Some companies will name them differently. They can name it qualification or whatever that comes to their mind. But this is an example. Usually you have like three big kinds of platforms: staging, some intermediate between staging and production platform, and of course the production platform. On this platform, you have everything laid out and shaped the exact same way it's done on production. You have the same kind of databases, you have the same methodology to deploy, you have everything the same. So the QA can test as if they were on real conditions, but they are not, of course. If things break, it doesn't matter, the customer is not impacted, you're not losing any money, and the CEO can buy its fifth Ferrari car. No worries. Crisis avoided. So as soon as the QA are done testing, it can take them weeks, days, I don't know, it depends. If they do that manually, if they have some test suits, they will find bugs. And they will tell you, okay, here are the list of things you have to correct if you want to release the 16th version of your application. So you go back to staging platform, and maybe you go back to local development. You don't add new features, you don't fix new bugs. You fix the bugs that were not completely fixed, or the bugs introduced by the new feature, okay? We are like still polishing the 16th version of the application. We are not building the 17th yet. So you go back to testing, you go back to release candidate, and this time you're making release candidate 16-2, second release candidate of your application in version 16. Blah, 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 they will find bugs, go back, 16-3-4, and then the 16-4 is perfect. The QA cannot find any bugs, so it must be perfect. They have legitimately the best person on the world, so they know how to find all the bugs in the application. So you'll know for sure that things will go fine and can be used on production. So the next step is to go with the release phase. You release that to the customer. So you go to the production platform, and the ops are in charge of updating the platforms, updating the version, updating the database, because you were on Postgre 14 and now it's 16 maybe. You need a new component, you need a new RabbitMQ, you need a new whatever you name it. So the ops are in charge of doing that on the production platform. And then the client, which is the people buying croissant on Boulangerie Express, will be able to connect to the production platform and buy their stuff. Okay. Of course, those clients are better than QAs in terms of finding bugs because they don't understand the application well. They will try random stuff. They will try to break your production. They will try to find the security flaw. They want to have their free croissant. So they will try stupid things, and at some point, things will be broken. The application will crash. Some customers will get error 500 or something like this. So this is called an incident or a regression. Okay? What's the difference between the two names? Incident versus regression. Yes?
Incident is when something that was supposed to work is just broke.
Okay.
And regression is when something that was supposed to work is not working anymore after something happened.
Okay, so either something is supposed to work and doesn't work, or something is supposed to work and doesn't work?
So was working and is not anymore.
Okay, yes, this is, we can think of the regression as a smaller version of the incident maybe, or the incident. Okay, let's call an incident like very big problems. You have to stop what you were doing, like the devs and the QA were partying, having some champagne while the CEO is buying his 6th car. And they have to stop because Boulangerie Express doesn't work anymore. There were some, I don't know, memory overflow, there were some unbound check or access or something like this. There was something really bad, something nasty that was not found before. The client triggered it, the application is not working, croissants are not being bought anymore, the company is losing money. So you stop everything, you have an incident. When you have an incident, everybody is trying to find the source of the problem, the root cause, RC. Not this one, but another one. The root cause. And the developer will soon identify it, propose a fix. You'll go directly to production because you don't have time anymore. It doesn't matter. You need to fix things. It's already broken. You cannot break it anymore. So you'll go directly to production and you'll solve the incident. The regression or the bug is less problematic than that. Regression can be considered an incident if it's a big one, like you were able to buy, I don't know, you had an extension where you were able to buy pizza on Boulangerie Express and now it doesn't work anymore. This is like a huge regression, so this is considered an incident. But if you had this small feature that now doesn't work anymore, but it's not that bad, if you have like on the new feature you have added, there is a tiny bug, maybe a UX something, some word is truncated or something not that bad. You want to fix that, of course, but you can continue partying and buying the 7th car, okay? So this is only a bug or regression. And the last thing of the diagram, the beta/canary phase. Who can explain this? What is a canary, first of all? Yes?
It's just not out, but isn't it like a kind of testing application that's available to the user, so the user can submit bug reports?
Yes.
Free?
Yes. So what's a canary? None of you worked in a coal mine.
Yes.
You did?
No, but I know what a canary is in a coal mine. It's they take a canary, which is a bird, in some new shafts, and they see if the bird dies because of a lack of oxygen or not. And if it dies, then it's not safe to go
Yeah.
that mine.
More specifically than that, in coal mines, you have pockets of gas which is highly explosive. This happens and this is normal. Coal is like organic thing, and depending on how the organic stuff that lived millions of years ago degraded, it comes either as coal or as some highly explosive gas. So when you're mining in coal mines, you can come across coal and explosive gas pockets. Of course, the explosive gas pockets are quite bad. You want to avoid them. You cannot know where they are. And back in the time, like 100 years ago, where you were mining without any electricity, without any LEDs, you were mining with flames, like candles. And of course, a candle plus a pocket of explosive gas, it's really nasty. So they had to find a way to prevent themselves from blowing themselves up in the mine with a pocket of explosive gas. And the thing they have found out is canaries. The birds can sense the gas on very, very little quantities, and they were able to smell the gas before the human could or before the explosion. So they dragged birds in cages in coal mines, and as soon as the bird went crazy or even died, they knew that they had to chop off, like they had to move, because it was going to explode. This is called a canary. Now we don't use birds anymore, but we still kept the term. So a canary is a way of sensing if things are going well or not. You have your client bases. They are connected to the production platform, but you are going to make a new release. You have tested it, and you want to be sure that it will be fine even with clients that do weird things. Either you deploy, and if you have an incident, 100% of your client base is affected by the bug or by the incident, or you try to be clever. You put 99.9% of your clients to the production platform, and you select either randomly or voluntarily some clients, 0.1%, 0.01%, that will go to a canary platform. That is an exact same platform as the production one, but with the new version of your application. And you will try to observe the canaries, like do they face any incidents? Do they face any errors? Do they face any problems? If they do, you have found yourself an incident before it affected 100% of your clients. It only affected 0.1%, which is way less worse. During that time, maybe you were making only 99.9% of the money you usually make, which is very saddening, but thank God you can buy the 8th car. Okay, so this is called beta or canary testing, depending on how you shape it. Sometimes it can be explicit, like you can go to beta.boulangerieexpress.com, and you know that you're on the beta website with new features, but it might break at any time. And most of the time, you are not even aware of that. I have talked about Netflix. This is something very well known that they do. They put some random clients. They have no idea that they're on the beta platform, but they are actually on the next platform. Yes?
Is it like when, for example,
Yes.
actual ones, or not?
Yeah, it's most probably it's a canary phase. A lot of people, like a lot of companies, went for the canary approach recently because it's very efficient. And if it's a small change, if you're only canary testing a bug fix or something small, people don't notice and they don't mind. If you're completely reshaping the UX, adding a very huge feature with a red button in the middle, of course you have like a few people saying, "Wow, this is weird. I don't have this button," and some people enjoying themselves with the new feature. Most probably as Instagram is doing this. I have no idea if that's actually the case, but this is highly likely. Are we good on this diagram? Things are clear? So if I ask you to draw it back from memory, you will be able to? I'm joking. Or am I? No, the question is, this thing is great, but we are not talking about companies and buying Ferrari cars. We are talking about DevOps here, at least where it should be. So the question now stands, where is DevOps on the diagram? Salut! Okay, where is DevOps on the diagram? If I have to draw some, I don't know, like box saying, okay, this is DevOps, where should I draw the box? What should I include in? Yes?
From local to staging is already DevOps.
Okay.
And then it's highly likely that staging to QA is also DevOps, and QA to prod is also DevOps.
Okay, so you will put the box on this thing here.
Except for local.
Except for local. Okay, so put the box here. Okay. Who has another idea? Everybody agrees with him? Or you don't agree because you don't have an opinion? Or you're already sleeping or dreaming about the hamburger you're going to eat in a few hours?
I put only prod because it's the same color as ops.
Yes, but you're missing the dev part of DevOps.
Then the yellow part as well. So
Okay.
it's the same color as
Okay,
DevOps.
but not the QA one. Yes.
Are operations named to the client responsible for, like, when the client responds to the new feature, like the operation part of the DevOps takes answers and process them in order to
You do that, of course, but you wouldn't qualify that as DevOps. There is no strong connection with the DevOps approach or methodologies. Okay, let me jump to the next slide. This could be considered the DevOps scope. Okay, we exclude projects and product team sales, of course. CTO and CEO, they don't care about DevOps. They just know that these terms exist, but they're not doing any DevOps. They're not involved in this. Again, this is not true for all companies. This is true for most companies with 500 employees or so, something like this. If you're working in a startup where you have only one CEO that does everything, of course, he's in the middle. So DevOps being a set of tools and practices, it affects directly all the platforms here, even local ones, because you will be working on DevOps tools with quotes. And the way you're moving from RC to correcting or the release and things like this, this also is considered DevOps because you can have a DevOps approach of doing things. And not only the platform, but the people, when they interact with each other, DevOps also came with ways of making interactions easier and supposedly better, okay? So you could argue that everybody is involved. The QA must not be excluded because they're working with the devs and the ops and they're working with the tools and they have to know them and they have to know the practices. Same goes for the architecture, the security team or the other teams. They are implied. Some people are more DevOpsy than others, but usually in a company, all those people will be involved. Okay? So, next question we can ask ourselves. If we squint our eyes, we know that DevOps is something related to interaction with devs and ops and some tools and some practices. But why do we care about this? What are the actual issues solved by DevOps? Why is everybody talking about DevOps so psyched? What's the fuzz about it? Let's put myself into your shoes. Let's go with the POV of the dev point of view, which is actually twice point of view. Let's go with the dev point of view. You are working on your laptop. You have your own operating system. You, good sir, are working on Nix most probably. You are working on Ubuntu, you are working on macOS, you are working on Windows, why not? You have all different laptops with different versions of your OS, and it might impact the application. The application developed on the Nix platform may not work on a Mac platform. You have your own libraries. Being a Nix enthusiast, you have the latest version that you have compiled yourself with your own patch fix, which is good, but only shared by you. So your colleague here on Ubuntu, she doesn't have this version of the library. She's a bit late, like maybe a year or 2 years late in terms of updates on the computer. On Windows, it's even another library. Some guy is working on some Alpine Linux, because why not? And on Alpine, they don't even have the glibc. They have Muscle, which is completely different, but yet kind of the same. So you all have different libraries, different version of the libraries, different OSs. You all have your own environment. You have things that are different from a laptop to another. You have your own hardware specs. Can be simple as you have 2 gigs of RAM, you have 47, which is way better. So if the application requires 32 gigs, it works on yours, but not on yours. This could be it. Or it could be a bit more subtle, like you have a Mac M1 platform and you have an AMD CPU, which is AMD 64. You have like different subtle things, or less subtle, that vary from a laptop to another. You have your own network stack also, which is different. You may have like a good quality, like no packet loss, very small latency, high bandwidth, which is not the case from the remote developer that worked from Brittany because he's visiting his mother, etc., etc. You have a lot of differences. The question now is, how will you be able to ship this thing you have developed production without any troubles, without any hassle? The production is different from your laptop. It is by a fact, because, for example, my production servers, they have a terabyte of RAM. I don't think you have this on your laptop. We have like things like this that's completely crazy. And it won't behave the same. We are running some Debian 12 that we have recompiled the kernel. We have things that are completely different. So we have to make sure that the things you have developed and tested on your platform will work on production. And before production, that it will even work on staging, because the next step after local development is staging. Okay? What's the thing you have to worry about? What are the meaningful differences? Okay? It's likely that my Wi-Fi card, network card, is not the same as yours. Does it really matter for the application? I'm not sure it does. In the end, you still have Wi-Fi, it works kind of the same, it's exposed kind of the same way, but I don't have the same version of the libc as you do. Does it matter? Most probably it may. It's hard to tell, okay? This is the thing that is complex about the problems here. Most probably you know the meme where you said, yeah, but it worked on my computer. And the person in front of you is saying, but we're not going to give the computer to the client. This is not how it works. The client, they have their own computers. The service that the company has is different. So what are the meaningful differences? How will you introduce architectural changes? That is not about the application adding a new feature, but for the application evolution, you need a new database. You need a new service. You need a new, you name it, translation API. You need some, I don't know, AI that runs somewhere. You want to make big change to the application, which is not only the code, but requires external things to be deployed for you. How do you do that? Because on your laptop, you may be able to start, I don't know, a Postgre instance on the side and say, okay, now I have a new database, I can use it. But on staging, it won't be there. I have to deploy it for you because I'm the ops. And on production, this is the same thing. And a database needs to be deployed in a reliable way. The configuration must be tuned. So the architectural changes are quite difficult to introduce, especially when you don't know what are the impacts. Because as a dev, you don't really know how production platform is running, and you don't care. And it's normal. You don't have to care. how will you add a new dependency? How can I phrase it? Okay, let's say you are working on some JavaScript project and you want now a new library. You want to install CoreJS because why not? How do you make sure that CoreJS is installed on the production server? Maybe you need to, I don't know, use LDAP, some protocol. And for LDAP, you need some libraries. And the libraries, they're not installed on production server. How do we go and install them? You won't connect yourself as a developer to the production server. First of all, because you can't. And second of all, because it's not your job. But you have somehow to tell the ops, okay, now I need the LDAP libraries. Install them for me. How do you avoid it worked on my laptop thing? Because it happened on Epita IQ project where you tried locally and it worked, and on the Bullinet it doesn't work anymore. But it will also happen in the real world. How do we avoid that? But also, some questions, because those questions, I think, you can came up with them yourselves. If I were to ask you what would be the problems that DevOps can solve for you, maybe you can come up across you can come up with these questions yourselves. The next one, they're not the devs' questions. They don't care about this, but they have to, because upper management will tell them to care about that, especially how to reduce time to market. Do you know what time to market is? TTM? It's a business thing. The sales, they want to make money by selling the product, but they're not only selling the product you already have, they're also selling the product you're going to have. In the next month, you're making the release, you're adding a new feature, and they're already selling it because it makes money, it makes good money. What is trending right now? AI. Okay, you're going to have AI in Boulangerie Express, don't worry. We're going to select the best baguette for you with AI. Don't worry about it, in a month it will be on the application. This is the sales pitch the sales will have to the clients, so they can make more money. And it will make more money if you actually can develop this feature and make it available to the customer quickly, reducing time to market. This is time to market. It's the time between the idea of a feature created by the sales or the product, the design phase of the feature, the development, the tests of this feature, and the release of the feature. If you can squeeze this time as much as possible, you're more versatile, you're more quick, you can respond to the market needs as quickly as possible, and you can make more money. As a developer, you don't care, because your salary will be the same at the end of the month, unless you're your own boss, but the boss actually cares about this. Some other problem is that in 2 or 3 years, I don't know exactly, you will come in a company as soon as you're graduated from Epita. Maybe you will be a developer and you will join an existing code base. You will join a company that exists for 15 years or 20 without you. There were like hundreds of people that already developed the application. You were not part of them. You will work on this application. You will have to understand this thing. So it will be a great thing if you can onboard people quickly. If you need 5 months of training for the newcomer to understand the code base, it means that you're paying them for 5 months and they're not producing any value to you. If you can reduce that to, let's say, 1 day, you have 1 day of paying the developer for him to understand, for him or her to understand the code base, and then they can start producing code and creating value. So this is important, again, for upper management, not for you. As a developer, you don't really care. Or you do a bit, because it's better for you if you understand the things you're working on. Some of the points, you have experienced this already, but how do you work with coworkers? You know that you don't have the same experience as them, you're not from the same school maybe, you don't speak the same language, you don't have the same experiences. It will be difficult, okay? Right now in Epita, it's already difficult for you. If you have like a project groups, you're 4 working on some project, it's already tricky. Maybe it's a bit more hard than working alone. Like in real companies, you will be working with 20, 30 different people. They will have different backgrounds because one of them will be in the company for 20 years already. One of them is a junior, one is the intern that just arrived yesterday. One of them came from I don't know which country and they don't speak French or they don't speak proper English, they have a bit of a broken English or bigger, strong accent, or they're used to some practices that you've never heard of. They come with TDD, and you're like, whoa, I'm afraid of this, please stop. So you'll have to work with those kind of people, and it's okay. So if you have tools and you have good practices, it will make the job easier for you. Up. Let's switch to the ops point of view now, okay? This time, you will have to make the effort to try to understand my job and understand the problems I have, okay? So, I have a dev application. How do I run it? How do I deploy it? I have no idea. Maybe they give me some repo, like I have a Git repository. Maybe I have a Makefile in it, maybe not. How do I build the thing? How do I deploy? What is needed? If things are unclear, I will have to either ask and try to clarify them by asking. It will take time. I might not get the proper answer, or I will have to look at the code, look at some documentation, look at some readmes, look at some common files. I will have to retro-engineer the thing. So deploying the dev application can be very tricky if you have no idea how to deploy it. How to make sure it's working well? Okay, I can, maybe I have successfully built it, it compiled, I can run it. How do I make sure it's working? Like, okay, I can see I can see the program running, but is it doing the job it's supposed to? Are things okay? This is not clear for me as an ops. I have no idea. How do I know what the dependencies are? You have introduced a dependency to core.js. How do I know that? How do I install this? How do I make sure that those things are covered? How will I upgrade your thing without breaking anything? You can think of the egg and the chicken problem. You may have an application which depends on the database, and you say, okay, I'm making the version 2 of the application, so I need to make huge database changes, okay? So if you upgrade the application, the new application doesn't work with the old database because it's not the version 2, it's the version 1 of the database. So you have to update the database to version 2. But if you do so, the application in version 1 doesn't work anymore because the database is in version 2. So you will have to stop everything, upgrade everything, and then start everything back again. Or you have like troubles like this. So I need to understand what's the upgrade path, how do I have to upgrade things for things to be seamless, to be working fine, because I cannot just do that at any time in the day. I have clients that need to buy their boulangerie baguette express. So I have to make sure that things keep on working every day, 24/7. Most important question for us, how do I avoid differences between prod and dev environments? If the prod and the dev environments are the same, a bug that is triggered on dev will be triggered on prod, and vice versa. Meaning that if I have deployed to dev platform, staging platform, I test it well, I should find all the bugs that will be in prod platform as well. If it's not the case, I can find things on dev platform, but as soon as I release on production platform, I will find new bugs I could never have found without moving to prod. So having prod and dev environment the same will be way simpler and way easier to find the bugs and correct them in advance before it hits the customer. Some problem is also how do I handle configuration and secrets. Your application needs some secret for the database, it needs some secrets from some external API. How will I handle those things? How do I deploy them? And we can ask also the same questions. How do I understand years of ops without me being in the company? I join a company, the architecture has been created by people before. How do I understand this architecture? How do I know how it's working? Where do I have to look for information? This is not clear, maybe. How do I work with coworkers that are different from me? Same question. And to most of those questions, proper DevOps is actually an answer. If devs have some knowledge of how things are deployed, they can provide insights and they know what they have to give in terms of information to the ops. You have written a new feature. Do you want the ops about how well used red-black trees or binary trees and this LRU algorithm you came across because it was very cool for you. This is the new feature you've been working on and you found a super algorithm. Do you tell the ops about it, or do you tell the ops about the config file it requires and what's the format of the config file? And okay, you need a database, how it's supposed to be shaped. If you know what the ops are expecting, it's easier to give them what they expect. One thing also would be for the devs to have a bit of control on the ops side. For example, the libraries. The ops don't care about core.js library. I'm sorry to tell you about this, but honestly, we don't care about the libraries you're using. So if you think that core.js is a good library, feel free to use it and install it yourself. And if you have a bit of control, this will be easier. You don't have to tell me, install core.js, now install this library, now install that one, now install this one, because I don't care. I'm not doing any good job here. I'm not adding value. You can do that yourself if you have a bit of control on the ops side. This is very important. Of course, it needs to be limited, scoped, maybe supervised, because you're not ops, so you will be doing mistakes, most probably, and you don't have time to learn another job because you already have one, which requires your full undivided attention. So we need to put some boundaries here for this thing to be efficient, okay? And to not ask dev to manage two jobs at once. The control should be application oriented. You should be doing things that are required for your application. You're in charge of the application, you know how it works, you know how, you know better how its architecture, what are the dependencies and things like this. So you should have control on these parts here. And on the opposite side, ops should be involved in the dev process. They don't have to code features themselves, of course not. But they can try to focus on the dependencies. They can try to be involved in the deployment process. Maybe they will write the deployment process. So they understand the features a bit better. They know how the components interact with each other, so they can better understand when there is an incident. Okay, I cannot, there is this thing that goes wrong. I understand it a bit because I know that this thing connects to that one that does this job, and it seems that this job is not done anymore, so maybe there is a problem, like things like this. How will the issues be solved by DevOps? Of course, it's not magic. If you look at LinkedIn DevOps influencers, it is, but the sad truth is, no, it's not. We have some concepts. We are going to dive in some technical things. So the people at the back of the room, you have not listened to the course anymore for 15 minutes. This is now it's a good time to, keep your eyes up, perfect, thank you. So now it's a good time to focus again because I'm going to introduce a new thing that is actually useful, that you can read. It will take you maybe 40 minutes to read the 12 factors and it will change your life. This is not true, but it might. So the DevOps concepts are built around the 12 factors. What are the 12 factors? The goal of the 12 factors is in the end to have things as declarative as possible. If you clearly state somewhere in a file with a convention, with rules, what are the dependencies you need, it will be easier for people to work on this. Have you worked with Python, for example? No, okay, it's not clear. Okay, for Python, you have dependencies. And one way of having the dependencies stated would be to create a requirements.txt file on which you list all the dependencies with a common format. So you know that if you're working with a Python project, you look for requirements.txt and you have all the dependencies here. They are listed. They are always in requirements.txt. So you change from a company that works with Python to another company that works with Python. You don't know anything about the new company, but you know that you will have to follow requirements.txt. If you have a convention, a declarative one, it will be easier. This is just a simple example, but you have like plenty of things like this where being declarative is way easier for people to understand because they can look for the information they are trying to find, and they can do that by themselves. You have to understand the implication of the interactions you have between your application and the system, okay? I have asked if having a different version of the library is important. Most probably it is. Is having a different Wi-Fi network card important? Most probably it's not. To be able to tell that the first one is important and the second one is not means that you understand what the implications are between your application and the external environment. As much as you like, the more you know the interactions and the implications of those interactions, the better you will be able to shape the application and the deployment and the system as a general concept. Very important thing, no divergence between dev and prod. Those platforms must be as identical as possible. So if an issue is found on dev, it will be found before it reads production. And you don't have surprises, things that worked on dev that don't work anymore on prod. If you have no differences, this is covered. You want to be platform agnostic. You know what agnostic means? Okay, some people do. Being platform agnostic means that you don't care about the differences of the platform. You have found a way to declare what are the meaningful differences, and the thing that actually can't be covered and can't be the same, and you try to cover all the other differences by yourself. We'll see how we can do that. This is very important, but this is very vague if you don't know the tools for that. Some other concepts that we have not talked about yet is being able to scale up and down. You're not building, like the way I describe this point is by this metaphor. We are not building a single car, you are building a car factory. If your customers need more cars, you just ramp up the factory up. If they don't need that many cars anymore, you scale it down, okay? For Boulangerie Express, we are not building one instance of Boulangerie Express. We are building a way to have a Boulangerie Express service that will cover all the customer needs. Tomorrow we'll have 5 times the amount of customers we had yesterday. So we'll have to have the application being able to cope with the higher load. We want the application to be 5 times bigger in terms of capacity to handle those clients. Being able to scale up and down is very important for companies, especially if they are growing, okay? Which is the point of each company. They want to make more money, and to make more money, they need more customers, they need to sell more things, they need to be bigger. So, if we look at the 12 factors, for example, the first one, we're not going to cover all of them, but I incline you to look and to look for yourself and read them because it's very useful. So the first one of the 12 factors is the code-based one. It says that you should have, your application should be in one code base, tracked with revision control and many deploys. What does it mean? It means that your application must be in a revision control system, Git, could be something else, but Git, and you have only one Git for your application. Your application will be deployed locally on staging platform, production platform, etc., but you have only one Git, okay? One code base, many deploys. Very important thing. If you're looking for something Boulangerie Express related, you have only one Git repository to look for. You don't have the Boulangerie Express staging, the Boulangerie Express prod, the Boulangerie Express sandbox, I think like this. If you have multiple repositories, you will have issues tracking the differences between those repositories, okay? So one code base, many deploys. The dependencies part, it's the second point. Explicitly declare and isolate dependencies. We have said that a library is a dependency we care about. So we have to declare that we need this library. And we need to isolate it. We need to make sure that this library is, will be installed and will be the same version, very important thing, on all the environments. The config points. Config will be the next topic, so we are not going to get into more details here, but it says that the config must be stored in the environment, not the code. This is the 7th point, port binding. Your application is exposed to the customer over the network, because this is what people do now. And for this, you need to bind some ports. Your application will be listening on some TCP port. You have to explicitly declare which ports you're going to use and which by which entrance the customer should come in and by which entrance the ops, admin, monitoring, you name it, should come in. It might be different. So explicitly declare this. Otherwise, you have a black box and you have no idea how to enter until you try all the doors, and most of them are closed. It's very annoying for the ops. If things are declared, it's way simpler. The dev prod parity, I have explained this a few times already, so I'm not going to get back to it, but you have understood the concept. Is it clear for all those points so far? Okay. The 12 factors, they cover all the points, very important, but I just selected a few of them. Any questions? Okay. So what do we do with this? 12 factors, it's not a magical solution to everything. It's a white paper. It's some people that wrote those things saying, okay, this is how things should be shaped. This is how things should be because it sounds better. And most of the time they're actually right. The 12 factors, most of the points should be followed strictly because they are very important and they were well thought, well written, well made. But it's not a magical solution. It's not just apt install 12 factors and voila. It gives good advices, generic concepts, but DevOps is about mentality, so we get part of the mentality from the 12 factors, but also the tools. And 12 factors, they don't provide any tools, they just state how things should be. And it's on the tools to actually follow the 12 factors advices or not. And one way of seeing the mentality and seeing the concept here would be to actually look at the tools and how they work and how they follow or not the 12 factors. So this will be the next chapter and the last one for today. We're going to talk about configuration. I've talked about a few jobs already, developers, QAs, ops, but I have forgotten one, which is very important, YAML engineer. This is the unofficial name of my job. Like if you find me on my Slack, you will find a YAML engineer, which is very true because I spent, I don't know, 80% of my work time working on YAML. What is YAML, you will ask? We'll come to it. Configuration. We are going to focus on the third point of the 12 factors because this is something that is often badly made, badly implemented in applications, and which is shameful because it's frankly quite easy. Okay, so we'll get this point covered, and as soon as you have understood all the concepts, and in 40 minutes you're out of this class and you know how to handle configuration, and you will follow the third point of the 12 factors perfectly, and you have no problems with that. Oh, actually, I forgot. I want a bit of interaction. I want things. I want you to be involved. And one important thing I noticed when I give classes, in general, it's not me or you, is that when you're listening to someone speak, even if you're actively listening and not sleeping or anything, I don't blame you, I understand. Even if you're listening to the things I say and you try to understand, it will be hard to be sure that you have understood. You need to challenge yourself to see if you have well understood the concept. And this is the thing I have to work on. I have to be sure that I have talked about DevOps, about concepts, about 12 factors, about things like this. You have listened to me and you are like, yeah, okay, makes sense, And you're, I would say, honest about it. You truly think that you have understood the things. Otherwise, you would have asked questions. And I truly believe that. But the thing is, you are most probably, for the most of you, you're mistaken because you think you have well understood the concept, but until you actually have to work on them and try to maybe explain them to your neighbor or actually use them, you have to go through this phase to realize that some things are not fully clear actually. This is my job here. I'm trying to make sure that the concepts I present are very clear to you, that you can understand them, that they make sense, that we are building some logical connections and things like this. But I also need to make you realize that maybe you have not well fully understood all the things. And the way I have found is, of course, this one. How do I do that? Up here. Okay, so why do we have WHO claps? Okay. We have them because I need you to interact. I need you to be active in the class. I need you to wake up. I need you to find a way to challenge yourself, and it would be better if it's in a fun way. WHO claps are fun-ish. So let's do that. Actually, I'm just doing. Ah, okay, perfect.
I don't have access to the Google app.
Ah. Do people have access to it or not?
Yeah, but once we are logged in, we need to like log back off and back in. It's just weird. Super. But not the first time it does that.
Okay, so if it works for some people, it might work for everyone. Just need to.
It works on my machine.
Ah. J'ai désolé cliquer, c'est pas ça.
Juste refresh.
Non, refresh, ça marche pas.
Okay. Is everybody connected? Okay, let's phrase it the other way. Who is not connected yet? Okay. I'll wait 10 or 20 more seconds, and then we'll get started. So, what I'm asking you here is to try to answer the questions honestly. It's of course not graded. What's the point of the question is for you to, yeah, because it's from last year. You reset it every class, but I did a hard reset every time I did a course, and on the very last day of the last class last year, I found a way to soft reset it, to reset only the answer but not the people here. But I have all the engine promotion, so it's a bit more than 200 people. You are not 200 in this room. Okay, let's get started. What is DevOps? Is it a job, a methodology, or a tool? Yes?
I don't have access to the...
Apparently you have to log out and to log in again from the Forge, from the CRI. I'm not sure, but some people in the first row, they told me this. Yeah, it's simple to begin with. So, of course, you got it right. Please. Thank you. Of course, you got it right. It's a methodology. It is not a job if you look at the strict definition. If you look at the real world, it is actually a job, but let's keep to the strict definition for now. It is a methodology. It's not a tool. You don't have a DevOps tool. You have a set of tools that will help you implement the DevOps methodology. So the best answer, I believe, is the methodology here. Who is directly concerned by DevOps? R&D, research and development engineers, developers, ops, admin sys, QA engineers, cloud architects. Okay, so it seems like we have three kinds of answer. People saying DevOps means Dev and Ops, so just those two answers. This is not correct. We need to widen the scope a bit more. So we have the second kind of people, the people that followed the class, and they have looked at the diagram, and they remember that there were also QA engineers. So they added DevOps and QA engineers. But again, this is only partly true. The real answer is, of course, all of the points. Because R&D engineers, they will be working with the developers after, they will be working with other people, they will be working with DevOps tools. They have to know about DevOps. Admin sys, it's an alternative name for ops, or it's partially covered, like it's a bit different, but yet a bit the same, depends on who you're asking. So of course they're doing DevOps as well. And cloud architects, they are like the true quintessence of DevOps. They are like the people that snort DevOps for breakfast. Okay, I have tried this thing. I don't know how it works, but you will have to order the generic steps of software development from the beginning to the end. So you have staging platform deployments, production deployments, pre-production deployments, QA platform, local development, and canary release platform deployments. Okay, so on the left, I see how many people have answered, I guess. Hein? Le premier rang. C'était dans le même ordre, à la base?
Non, tu dis n'importe quoi d'abord.
Okay. Okay, should we correct? So those are the most frequent orders, and the first one is actually the correct one. So you get started from local development. I think everybody got that correct. You move to staging, then to QA with a release date, then the pre-production, and then you have this canary release. Where do you put it? Do you put it at the end? No, of course, production is the very final step. Okay, the canary comes before production. It's the way of finding the bugs before it hits the real customers. And this one, what does it have? No, pre-production is after QA. On QA, you test that the application is correct, that it follows the quality you expect. And pre-production is a way of checking that things are exactly working as intended. I have partially lied to you, guys. I have partially lied to you. In most companies, QA platforms are not fully similar to the production ones. They are not on the same hardware because it would be too expensive. They're not sized the same way because it would be too expensive. So usually, staging platforms are a bit shittier than the production ones. And we try to make sure that it's still okay. Another big difference. Have you ever heard of our Lord and Savior RGDP, GDPR in English? GDPR, Règlement Général pour la Protection des Données, the famous European law that says that you have to be very careful about the data, the personal data, private data of people, and because of that, in most companies, it's a good way, it's a good practice to not have the real customers' data on the staging platform because it's not as secure. You may have leaks and things like this, especially if you're working with credit card numbers, for example, or sensitive information like this. But even email addresses, name, birth date, and things like this are sensitive information. You want to keep them. So on the staging platform, you may not have the, you will not actually have the production platform database and the data actually, which means that you have a big difference because the data actually matter. You may have a bug that is not triggered on the staging platform because the data is shaped differently and you have not think of a corner case or something. For example, at the CRI a few years ago, in 2018 when I worked there. We had the Itrakri that you already know because it's still there, and we were moving from, please, logins. The logins used to be last name underscore first name of the given name. So my login was Duval G, not C because it was already taken, and it has moved to first name last name with a dot. So my new login would be Cyril.Duval. So we were like, okay, no worries, let's change the database to cope with this change. And how long should a name be? Let's say 32 characters because it seems long enough. And then we had, who became my colleague after all, Melchior de Roquefeuille de la Gorce, which broke the database system because his name was too big. And on staging platform, we didn't find this out because we have not loaded real production data inside the database. So we had actually this bug that was not triggered before. So this is why it's important to have a platform which has the production data on it, but it's not accessible by anyone, which is still kept secure and things like this. So this is the role of the pre-production. You're as close as possible as the production one. The size is the same, it's big, it costs money, it has sensitive data, but you have no customers on it, so you can still test it and be sure that it works well, okay? So this is the role of the pre-production, and this is why it's different from the QA platforms. Okay, good? Let's move forward. What is or are the issues solved by proper DevOps? DevOps well implemented. Dependencies handling, incompetent people, DDoS attacks, friction between devs and ops, human mistakes in manual deployments, and my English accent. Okay, let's correct. So I think it's fairly straightforward. Most people have the right answers. Of course, dependency handling, friction between dev and ops, it's obvious, and human mistakes in manual deployments. With DevOps, the idea is to not have manual deployments at the end. You automatize everything. You try to correct mistakes. You try to be declarative. You declare how things should be, and the system, the machine, will do that for you. So you try to remove and erase human mistakes. If you're not doing DevOps and you're still doing things manually, it would include, for example, installing the CoreJS library on the 500 virtual machines you have in your company. So it would mean that somebody will have to connect on those 500 machines and apt install CoreJS, which is not the good way of doing. And if you were to do that, if you were to have manual deployments, at some point, the person will make a mistake. It will skip a machine because it has forgotten. It would skip to apt update before, and it would install an outdated version that somehow is not compatible. You will have human mistakes. If things are manual, people make mistakes. If it's automatic, the computers don't tend to make mistakes. They, most of the time, tend to do what they're being told to. And of course, the two other points, incompetent people and DDoS attacks are completely irrelevant for that. And my English accent is what it is. What are the 12 factors? 12 rules to follow to hire a DevOps engineer, 12 rules to use to be DevOps, and 12 reasons to use the DevOps approach, 12 guidelines to have a DevOps approach. We don't have an underdog that don't want to vote for the guidelines. Okay, so of course, Of course, you got it right. It's very simple. Let's move to the next question. What does it mean to be declarative in a DevOps context? It's the opposite of being imperative. A declarative person communicates efficiently with other people. Every dependency, configuration is declared, whatever that means. It's somewhat connected to the 12 factors. It's about declaring what is expected of other teams. Okay, so number 3 is the most answered and is correct, actually, yes. If you're declarative, you declare the configuration, the dependencies, and things like this. But not only. It's also connected to the 12 factors. The 12 factors, they try to make you declarative in most of the points, okay? Having your code in a VCS, version control system, in Git, means that you are actually declarative about the code and the version. One can simply go to your repository and look at the commits and understand the change and understand why things were made this way and see where the releases are and things like this. Second point, declarative person communicates efficiently with other people. This is not related to DevOps, okay? We are not covering the communication part and the say language part here. Declarative is the opposite of imperative. This is true. When you declare things, you have to understand the approach. In DevOps, you will be declaring how things should be. Like, okay, I want this thing to be shaped that way, instead of telling the machine how to do it. The machines already know how to do that, so you just tell it what's the final step, what are the things you want how you want things to be represented, and the machine, with the tools you have, will lead you to this way. And it's about declaring what is expected of the other teams. Not quite, okay? The teams know what they have to do, and they know what's expected of them, but they have to be declarative in the communication with other teams about the dependencies, configuration, etc. Which situations could be considered as connected to a DevOps approach? Continuous deployment of the app through automation, manual testing of the app after a release candidate, using Git as a source of truth, different deployment methods between staging and prod platform, having common configuration for the app in the code, establish clear layout and coupling of the app external needed services, establish common ground between teams on some resources, Git, CI/CD, etc. Okay. Okay, so what are the correct answers? Continuous deployment of the app through automation. Yes, this is very DevOpsy. We want things to be automated. We want the computer to work for us and not the opposite way. People, please. Okay. Using Git as a source of truth. Yes, this is the very first point of the 12 factors. We want a single version control system. We want to establish clear layout and coupling of the app to external needed services. We want to be the application needs an external service, it needs to connect to a database, we want to clearly establish the connection between the application and the database. It must be clear, it must be well understood. We must know if the connection is required for the application to work, or if it's only something we would like to have, and if it doesn't work anymore, the problem, we don't have any incident, we don't have any problem. This needs to be understood. And we need to establish common ground between teams on some resources. Git, for example, the dev and the ops must understand the Git repositories of each other, maybe have a common Git repo, maybe have access to each other's repository, deployment with the CI/CDs, etc.
Why is the fifth one not correct?
The fifth one, having common configuration for the app in the code. The thing that is not correct is the last bit, in the code. The common configuration must not be in the code. Okay, this is something we'll see in, that you can read in the second point of the 12 factors. It's very important for the configuration to be separated from the code. And this is what we're going to see quickly now. Very first point, strict separation of config from the code. You have an application. Okay, let's take something you already know. Find. You have used this command line tool already, right? To find files and things like this. Have you done the project where you have to recode it?
Yes.
Okay, perfect. So you know how it works. You can argue that find has some sort of configuration. If you run find with arguments, it's not the same kind of find, okay? If you do find dash type D, you're not having the same output. It's not working the same way as just running find without any arguments, right? If you want to build your find tool, you wanted to build it the right way, you have to separate the configuration from the code. The code is the code of find, and the configuration will be the flags you apply at the running time, okay? You don't want in the code to only look for directories, and tomorrow you want to look at directories and files, so you will change the code. No, the code remains the same, but the configuration changes, okay? Find is a very stupid example, but if we take your application Boulangerie Express, which connects to the database of customers, the database is not the same for your local environment than the staging one, than the pre-production one, than the production one, okay? So if in the code you have hard-coded the value of the database, like connect to database.example.com, you will have to change the code from staging to production to etc. This is bad practice. So as soon as you have configuration, it needs to be externalized from the code, so the code remains the same everywhere, and just the configuration changes. So for the database endpoint, we'll just have to provide your Boulangerie Express application with a configuration file that says, okay, I want to connect to database here, to database there, etc., etc. Very important. Configuration shall not even be in the code VCS. This is partially true. If you read the Article 3, I think this is what they state. This is not something that you will find everywhere. Configuration should be in VCS. It might not be in the code, in the same repository as the code. You may have a repository with the code and a repository for the deployments with the different configurations for the different environments. This is perfectly acceptable. It might be in the same repository. I find it's okay. This is where the 12 factors are more guidelines than strict rules. It's about how you perceive things. Yes?
What does VCS mean?
A version control system, Git. You can replace VCS by Git because you will most likely never see any other VCS than Git. I hope for you. So this is what the 12 factors state. I'm not sure I fully agree with it. Depends on people, depends on the company, okay? But what is clear is that the configuration shall not be inside the code. This is very, very important. But could and should be stored in another VCS, yes. Last point is also very important. Never, never, ever store any secrets in plain text in a VCS, okay? You have a password for your database, you don't put it in the VCS, okay? Otherwise, people will have access to the password. And this is very, very important. We have ways of providing passwords, like multiple ways. We have projects, we have tools developed for that. We don't do that anymore, okay? The only sane passwords you can put in a configuration is the local test one, for example. This is acceptable. We don't care. The password might even be password or empty or whatever. It doesn't matter, so it can be stored in the VCS. If it's a real password for a staging platform, for a production platform, especially in production platform, never in the VCS. The configuration will be different between dev, staging, and prod, of course. So what is configuration? Everything removing genericity. Okay, your application is generic. It works with a database. No matter where the database is exactly located, it doesn't matter. So if you specify in the code that the database must be at a very specific endpoint with a very specific TCP port, specific user and password, your application is not generic anymore. If your application reads from a configuration file the details about the database and where to connect, your code is generic and you have configuration. Everything that can change from an environment to another, okay? So if you are considering changing the code because dev and platform and prod should not behave the same, you're most probably looking at a configuration and not about proper code. Address of the database, IP port to bind to, log level, how much logs you want to emit. We'll talk about that later. The path where you want to store the data. Maybe on your laptop it will be /home/Jonathan because you are named Jonathan. But on production servers, you are not named Jonathan. You are named SRV data whatever, etc., etc. How do we provide configuration? We have few ways. Environment variables. Have you worked with envars before?
Yes.
Okay, so you know them. Perfect. This is recommended for simple cases, but it's limited. With environment variables, you can only store key value things. You can store database address equal this thing. But if you are to connect to multiple databases, how do you represent that with an env variable? You can put commas maybe, or semicolons or something like this, but then you start to be limited because it's not meant to work with format other than key equal value. So most probably you switch to config files at some point if you have some application complex enough. It's a bit more complex to set up, to provide, but you will be more advanced in the way of representing the configuration. You will have lists, you will have mappings, you will have things like this. You can repeat bits of configuration. It's at some point it becomes necessary. So the question now is, how do I write a config file? If I provide you with an application already written that can connect to a database, and I'm just saying, okay, now you have to read the database address from a config file. How do you do that? How the config file will be shaped? Yes?
Ideally, in the code, we would want an object that would represent the whole config and reflect the representation of the object in some structured format, which would be most likely JSON, TOML, YAML, whatever. Okay, so you're already mentioning TOML, YAML, or JSON, which is very important. This is the very important, the most important point here. You don't create a new format, a new language to store configuration. People have done that before. They are most probably more clever than you because they have spent more time working on this configuration format and the files. There are already libraries that exist in all the languages for all the classic formats like YAML, TOML, or JSON. Very important point in Epita that you're not taught to: don't reinvent the wheel. It has been invented like 5,000 years ago. Don't reinvent it. It doesn't make sense. People have invented perfectly functional configuration formats. You don't need another one. And in DevOps tools, one stands above the other. It's YAML. You come across YAML everywhere on DevOps tools. We have 5 minutes left. I would like to have your undivided attention during those 5 minutes, and then we'll go and have lunch. Okay? YAML stands for yet another markup language, because we've had 14s
already, so we need a 15th one. It obviously makes sense. It's used in a lot of projects. I'm not going to name them all and explain them, but trust me, it's useful. It's a superset of JSON to make it human readable. What does it mean? JSON and YAML are strongly connected to each other. JSON doesn't know about YAML, but YAML knows about JSON. JSON is very useful. It has a very structured way that is used everywhere, and it can cover most of the use cases of configuration. But what JSON is not is human readable. It's not friendly. It's ugly-ish. So we want JSON to keep this structure that it has, but we want it to be human readable. So YAML took JSON and expanded it to be better. Any JSON format file is YAML format, okay, is YAML format compatible, okay? You give any JSON file to a YAML parser, it will understand everything perfectly. Small JSON snippets embedded within a YAML file are valid, okay? If you start writing YAML and in the middle of the YAML file you write a bit of JSON, this is okay, it works. It's understood and it's standard. It has the .yml or YAML extension, we don't care. And you have libs in every language to parse it. Don't do that yourself. You're going to waste time that has been invested by people on this. YAML is a key value format. You have a key, a string, and a value, and the value can be of multiple kinds, okay? The simple one is a string, okay, so Toto, Tata, okay, string to string. It can be an int, 42. It can be a boolean, true, false. It can be a list of other elements that can be themselves string, int, boolean, or list, or something else. We have a mapping. A mapping is an association of a key to a value. So you can have like a key that gives a mapping, and the mapping itself is a key that connects to a value. So you can have like nested mappings. You can have nested things. And the most important thing is the indentation. This is what gives YAML the format human readable and parsable. It's the indentation, like Python, okay? Python, you remove the indentation, it's not Python code anymore. And you can use quoting, but it's not mandatory, unlike JSON, which makes it more human readable. Let's look at this, and then we'll call it a day. This is a YAML file, okay? We start with 3 dashes. This is optional, and this indicates a beginning of a YAML configuration file, okay? We can remove them. They're not useful here, but it's best to know that, okay, guys, you don't know about this. Please listen to me. Then we have, like the YAML document here is a mapping. We have keys associated to a value. First one, key 1, is associated to a value, which is a string. Key 2 is an int. Key 3 is an int. There is no float in YAML, but yes. Key 4 is what? A string. We wanted 1.0 to be a string because for some reasons, but if we just write 1.0, it's interpreted as an int. So if we put quotes, it becomes a string. Okay, great. Key 5, what is it? A list of what? List of int, perfect. Key 6, what is key 6? It's a mapping, yes. Key 6 is a mapping of other keys to other values. So we have another key, subkey 1, which is a value with a quote, and we have, like, in the end, the value of subkey 1 is value with a quote with the double quote, okay? But if we want the quotes to be around value, like if the value we truly want is double quote, value, double quote. If we were to put double quote, value, double quote, the double quote will be interpreted as a way to escape the value, like we did here. Like in the end, the value here is 1.0. It's not quote 1.0. So if we want the quote, we can use single quotes, then double quotes. So now we show that we have full quoted with double quotes. So this is an exception. This is a specific. And then we have subkey 3. What is subkey 3? A list of
mapping.
It's a list of mapping. Very true. And key 7 represents a mapping, and we see all the versions of booleans. All of these are valid booleans. True, false, yes, no, on, off. are the 3 ways, or the 6 actually, to represent a Boolean in YAML. Very confusing, don't get mistaken for that. And yes, we'll stay to this one. Just before I release you, I'm going to put the slides online. I'm going to put a link on Moodle and things like this. And you don't have to do anything for next class.
Thank you.